Hello, this is Graham Lewis and I'm here this afternoon to talk about differentiating x to the power n from first principles. So we know the first principles formula, if it exists, f prime of x or f dash of x, depending which country you're listening from, is the limit as h tends towards 0 of f of x plus h minus f of x over h. Now I'm going to prove it only for n being a non-negative integer, so just for values of n like n equals 1, 2, 3, 4, 5, 6. So I'm not going to do it for fractions like 2/3 or negative numbers like x to the minus 2, even though it can be proved for that. This is a simpler proof. So if we consider f of x equals x to the power n, the tricky bit is really putting it into this part of the formula, f of x plus h, because we have a little bit of work to do to work out f of x plus h. So here we go. F of x plus h is x plus h to the power n. We need lots of room for this, so here we go. So I'm going to use the NR notation. If you're not familiar with the NR notation and are more familiar with the n choose R notation, you can check out one of my other videos which explains the NR notation. So x plus h to the n is n0 times x to the n plus n1, x to the n minus 1, introducing the first power of h, plus n2, x to the n minus 2, increasing the power of h to h squared. We'll just do one more, n3, x to the n minus 3 times h cubed. And I'm going to put plus dot dot dot, because obviously when I've got power n, there will be n plus 1 terms altogether. So let's simplify this. So in a previous video I showed how you can actually write n1, for example, here as n over 1 factorial. n2 is n minus 1 over 2 factorial. n3 is n minus 1, n minus 2 over 3 factorial. I'll tell you an interesting story. I remember being in a lecture, in my first lectures at my university, and I didn't know what 0 factorial was. And so I asked the student next to me, what's 0 factorial? And she didn't know either. So because the professor was using it. And so I was like 18. So 0 factorial is defined to be 1. And if you think of n0, we know that that's equivalent when n is a non-negative integer, n choose r. So we can write it as n factorial over r factorial, which is 0 in this case, n minus r factorial, so n minus 0 factorial. And just doing the algebra quickly, you get n factorial over 0 factorial, n factorial. Assuming n is non-zero, that it's a positive, non-negative integer, we can cancel the n factorials and we end up with 1 over 0 factorial. Now we know that the coefficient of n0 is 1, so the only way that this can work is this is equal to 1, and hence 0 factorial must be defined to be 1. So there's a neat little aside of why 0 factorial has to be 1. Back to our problem here. So n0 here, we know is equal to 1. So I'll write a 1 there, x to the power n, plus n over 1 factorial, x to the n minus 1 h, n2 plus n2, which is n minus 1 over 2 factorial, x to the n minus 2 h squared, plus n3 is the n minus 1 n minus 2 over 3 factorial, n minus 3, x to the n minus 3 h cubed, plus dot dot dot. So now we're in a position to put it into our formula up here, which I'll call star. So let's put it in our derivative of formula, assuming that that limit exists so we can actually write it. So f dash of x is equal to f of x plus h, the limit, as h tends towards 0, of f of x plus h, which is all this, I'll write x to the n, plus n x to the n minus 1 h, because n over 1 factorial is n, plus n minus 1, over 2 factorial, x to the n minus 2 h squared, plus n minus 1, n minus 2, over 3 factorial, x to the n minus 3 h cubed. Make this a bit smaller so we can see it. Plus dot 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 minus f of x, which is x to the n, all divided by h. So let's tidy this up a bit. I'm going to take out, copy down the limit of h tends towards 0. Haven't done the limit yet. Take out h as a factor on the top. Cancel the x to the n's nicely. Take out h on the numerator. So let's have a go at this. So this one will be an nx to the n minus 1 once I've taken the h out. The next one, the h squared here will change to an h. So n minus 1 over 2 factorial x to the n minus 2 h, because I've taken an h out, plus n minus 1, n minus 2 over 3 factorial x to the n minus 3, and I've taken an h out, so that becomes h squared, plus dot dot dot. Think carefully. All of the other terms are going to have h in them, at least one h. The next term here would have an h cubed, the one after h to the 4, h to the 5, increasing, increasing. So over h. So I can cancel these two h's, which is beautiful, thank you for that. And now let's think about this limit. So I've now got the limit of h tends towards 0. I'm not going to write all the terms this time, of nx to the n minus 1. Notice that does not depend on h. Plus n minus 1 over 2 factorial x to the n minus 2h plus, and I'm going to write dot 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 because every other term has an h in it. So what happens when it's got an h in it? The next term here has got an h squared, the one after h cubed. So when we take the limit of h tends towards 0 of something times h, it's got to be 0. So all of the limits of this term has to tend towards 0. The next term here would have an h squared in it, would have to tend towards 0. All of the subsequent terms would all tend towards 0. So the only thing we're left with when we take the limit of h tends towards 0 is actually nx minus nx to the power n minus 1. And of course that doesn't depend on h. So the limit of h tends towards 0 of all of my expression is just nx to the n minus 1. And we've proved for non-negative integers that the derivative of x to the power n is nx to the n minus 1. Thank you very much for watching. I hope you enjoyed the video. Please check out some of my other videos, and also try doing some differentiation from first principles. Maybe try 1 over x or x to the minus 3. Try some different functions as well. Thank you very much.